All right, let's unpack this research paper.
Okay.
It's called ETHOS, Transformer for Zero-Shot Health Trajectory Prediction.
Sounds complex, right?
Yeah, it does.
But trust me, it gets really interesting.
I believe you.
We're diving into the world of AI.
The world of cutting-edge AI.
Yeah, and how it could revolutionize healthcare.
Okay.
So you'll be hearing about this new AI system called ETHOS, short for Enhanced Transformer for Health Outcome Simulation.
Yetchi.
It analyzes patient health data, and it predicts future health events.
Wow.
Kind of like a crystal ball for healthcare.
Right.
But based on data, not magic.
Okay, I'm intrigued. So how does it work? Does it just gobble up medical records
Wow.
and spit out predictions?
Not quite.
Okay.
It's a lot more sophisticated than that.
Okay.
ETHOS is built on something called a transformer deep learning architecture. You might have heard of this tech.
I might have.
It's the same thing that powers those impressive language models.
Oh, like
ChatGPT. But instead of predicting the next word in a sentence,
Right.
ETHOS predicts events in a patient's medical journey.
So it's like it's reading a patient's medical history
Yeah.
and then writing the next chapter.
That's a great way to put it.
Okay.
The researchers call these detailed chronological records patient health timelines, or PHTs.
PHTs, okay.
They've packed these timelines with everything.
Everything.
Hospital admissions, medications, lab results, even the time between events.
Wow.
And they've converted all this data into a code that the AI can understand.
So ETHOS learns from these PHTs
Exactly.
and then uses that knowledge to predict what might happen next.
Precisely. It creates something called a future PHT, or FPHT.
FDHT.
And here's where it gets really interesting. ETHOS has this incredible ability called zero-shot learning.
Okay.
This means it can perform various tasks without needing specific training for each one.
So like a multi-talented AI
Yeah.
that can switch between jobs seamlessly.
It's like having a single AI tool that can predict mortality risk,
Right.
estimate ICU length of stay, and even suggest potential treatment plans.
All without having to be reprogrammed for each specific task.
Exactly.
Wow, that's impressive.
Yeah.
But how do we know if it's actually any good at making these predictions?
Well, the researchers put ETHOS to the test using a massive database called MIMIC.
Okay.
This database contains anonymized health records from over 200,000 patients.
That's a lot of data.
And here's the key. They use the MIC for data as is,
with
all its real-world messiness and inconsistencies.
Oh, so like real-world data.
Yeah.
Not like some perfectly curated data set.
Exactly.
Yeah.
This means ETHOS had to learn to deal with the kind of messy data it will encounter in real healthcare settings.
Interesting. So how did it perform? Did ETHOS actually make accurate predictions with all that real-world data?
The results were pretty remarkable. For instance, when it came to predicting hospital mortality, ETHOS achieved an AUC of 0.921.
0.921.
For predicting ICU mortality, the AUC was even higher.
Higher.
At 0.927.
Okay, I know you mentioned AUC before.
Yeah.
But what exactly does that number tell us?
Right. Good point.
I need a reminder.
AUC stands for area under the curve. And it's a way to measure how well the AI distinguishes between two possibilities.
Okay.
In this case, it's distinguishing between patients who will survive and those who won't.
So a higher AUC means it's better at telling them apart.
Exactly.
Okay.
An AUC of 1 represents a perfect prediction, and 0.5 is as good as random guessing.
So anything above 0.5 is better than flipping a coin?
Basically.
Okay.
So an AUC above 0.9
Right.
means ETHOS is doing a pretty good job.
So those numbers you mentioned, 0.921 and 0.927,
Yeah.
mean that ETHOS is quite accurate in its predictions.
Exactly.
Okay, that is impressive.
What's even more impressive is that it actually outperformed some specialized algorithms that were specifically designed for predicting those outcomes.
So it's not just good, it's better than some of the existing tools.
And remember, it did all this without specific training for those tasks.
That's pretty remarkable.
Right.
So it can handle this messy real-world data.
Yeah.
Make accurate predictions without additional training for each task. How does it manage that?
Yeah. That's where the technical wizardry comes in.
Okay, bring on the wizardry.
The paper goes into the details of the quantile-based tokenization strategy used by ETHOS.
Okay, I'm going to need you to break that down a bit.
Okay.
What does that mean in simpler terms?
Well, imagine you have a patient's blood pressure readings. Instead of trying to make sense of the raw numbers,
Right.
ETHOS might categorize them as high, medium, or low.
Okay.
based on where they fall within certain ranges.
I see.
These ranges are called quantiles.
On task of that.
This simplification helps the AI focus on significant clinical changes
Okay.
without getting bogged down in minute details.
So it's like creating a summarized version of the data
Mm-hmm.
for ETHOS to work with.
Exactly.
Oh.
And this approach works surprisingly well even for complex medical data,
Oh, wow.
like SOFA scores, which are used to assess organ function in ICU patients.
And ETHOS can predict those scores accurately
Yes.
using this simplified approach.
It can even predict things like DRG codes, which hospitals use for billing and resource allocation.
So it has applications beyond just clinical predictions.
Right.
It can also help with the operational side of healthcare.
It highlights how ETHOS can improve clinical outcomes
Yeah.
while also making healthcare systems more efficient and cost-effective.
Okay, I have to admit, this is all starting to sound like something out of a sci-fi movie.
A little bit, yeah.
Predicting a patient's future health trajectory based on their medical history
Mm-hmm.
and making healthcare more efficient.
Yeah.
This could be a real game changer.
It truly has the potential to revolutionize healthcare.
But
Ow.
it's not all smooth sailing.
Right.
There are still some challenges to overcome.
There are.
I bet it all sounds a little too good to be true.
It does.
What kind of challenges are we talking about?
Well, for one, incorporating more diverse data types into ETHOS could enhance its predictive abilities.
Okay, so expanding the types of data it can handle.
Yeah. And then there's the question of explainability and transparency.
Explainability. What does
Yeah.
that mean in the context of an AI like this?
It means understanding how ETHOS arrives at its predictions.
Okay.
Doctors and patients need to be able to trust the AI's recommendations.
Right.
And that trust is built on transparency.
Mm-hmm.
Right now, it's kind of like a black box. We know it works,
Yeah.
but we don't fully understand why or how.
So the next step is figuring out how to open up that black box a bit.
Exactly. The researchers are actively working on this, and
Yeah.
I'm eager to see how they tackle this challenge.
This is all incredibly fascinating.
It is.
We've covered a lot of ground already.
Mm-hmm.
From how ETHOS uses transformers to process data
Yeah.
to its impressive ability to predict various health outcomes.
Mhm.
I can't wait to dive deeper into the potential applications and implications of this groundbreaking AI.
I'm ready when you are.
Let's do it.
We've only just scratched the surface of what ETHOS might be capable of.
I can't wait. All right, so we've established that ETHOS can analyze complex medical data
Right.
and make some pretty accurate predictions.
Yeah.
But how does it actually do that? What's going on under the hood, so to speak?
That's a great question.
Lay it on me.
It takes us deeper into the realm of transformers
Oh,
and how they work their magic.
Ooh, magic.
Remember, ETHOS uses this transformer architecture,
Hmm.
which is particularly good at understanding sequences of data.
So like how the words in a sentence follow a specific order.
Yeah,
The events in a patient's health timeline also form a sequence.
precisely.
Oh.
And the beauty of transformers is that they can capture the relationships and dependencies between these events.
I see.
Think of it this way. Each event in a patient's timeline is like a word in a sentence. And just like a word's meaning can change depending on the words around it,
Right.
an event's significance can also depend on what happened before or after it.
So if a patient is admitted to the hospital
Yeah.
and then receives a specific medication,
Mm-hmm.
that sequence of events might tell us something different than if those events happened in reverse order.
Exactly.
Good.
Transformers are really good at picking up on those nuances.
Okay.
They can analyze these sequences of events
Mm-hmm.
and figure out which patterns are associated with certain outcomes.
Okay, that makes sense.
Yeah.
But we're talking about complex medical data here.
Right.
How does ETHOS even begin to make sense of all that information?
Well, that's where the concept of tokenization comes in.
Tokenization.
Remember how we talked about ETHOS simplifying data by using quantiles?
Right, like categorizing blood pressure readings as high, medium, or low?
Exactly.
Okay.
That's part of the tokenization process.
Mm.
Essentially, ETHOS breaks down all that complex medical data into smaller chunks or tokens that it can understand.
So smaller bytes.
Yeah, it's like taking a long paragraph of text
Yeah.
and breaking it down into individual words.
So instead of trying to process a whole patient's medical record at once,
Right.
ETHOS looks at piece by piece.
Precisely.
Okay.
And each piece or token represents a specific concept or piece of information.
Gotcha.
This makes it much easier for the AI to analyze the data and identify patterns.
Okay. I'm starting to get the picture.
Good.
But there must be a ton of different tokens
Oh, yeah.
to represent all the possible medical events and data points.
There The researchers actually created a special vocabulary of tokens specifically for ETHOS.
A whole vocabulary just for ethos.
They call it the PHT vocabulary.
The PHT vocabulary, okay.
And this vocabulary contains tokens for all sorts of things.
Like what?
Diagnoses, procedures, medications,
Mm-hmm.
lab results, vital signs, you name it.
Wow, that must be a pretty extensive vocabulary.
It is. It contains over 20,000 tokens.
20.
Which allows ETHOS to capture a wide range of medical information in a standardized way.
So each patient's health timeline is essentially turned into a series of these tokens.
Exactly.
Okay.
And that's the information that ETHOS uses to train and make predictions.
I see.
It learns to identify which sequences of tokens are associated with certain outcomes.
Okay, I think I'm starting to grasp the technical side of things a bit better now.
Good.
But let's go back to the impressive accuracy of ETHOS.
Yep.
You mentioned AUC before.
Right.
But I'm still a bit fuzzy on how it's calculated.
Sure, let's break it down a bit further.
Sure.
Remember, AUC stands for area under the curve,
Mm-hmm.
and the curve in question is called the ROC curve, which stands for Receiver Operating Characteristic Curve.
ROC curve. Okay, that sounds a bit intimidating.
It's not as scary as it sounds.
I hope not.
The ROC curve is basically a graph
Okay.
that visualizes how well a model can distinguish between two different classes.
Two different classes, okay.
In our case, it's distinguishing between patients who will experience a certain health outcome,
Like mortality.
like mortality, and those who won't.
So it's plotting the true positive rate against the false positive rate at different thresholds.
You got it.
Right.
And the area under that curve, the AUC,
Right.
gives us a single number that summarizes the overall performance of the model.
So a higher AUC means ETHOS is better at separating those who will experience the outcome
Exact.
from those who won't.
And remember, an AUC of 1 means perfect prediction,
Mm-hmm.
while 0.5 is basically random guessing.
Right.
So the fact that ETHOS achieved AUCs above 0.9 for predicting mortality
Yeah.
in both hospital and ICU settings is quite impressive.
That makes a lot more sense now.
Good.
So it's not just about being right or wrong,
Right.
but about how well the model can distinguish between those two possibilities.
Precisely.
Okay.
And that level of accuracy is what gives ETHOS its potential to be a game changer in healthcare.
Okay, so we've talked about tokens,
Yeah.
vocabularies,
Mm-hmm.
and how AUC is calculated.
Right.
What other technical details are worth highlighting?
Well, the paper also delves into the specifics of how ETHOS handles different types of medical data.
Okay. Different types of data.
For example, they use something called quantile embedding to represent numerical data,
Quantile embedding.
like lab results and vital signs.
That sounds familiar.
Yeah.
Is it related to the quantile-based tokenization we talked about earlier?
You're right on the mark.
Okay.
It's basically a way to represent those quantiles, those ranges of values,
Right.
as vectors in a multidimensional space.
Vectors. Multidimensional space. Okay, I'm starting to feel a bit lost again.
Don't worry, it's not as complicated as it sounds.
Okay.
Think of it this way. Imagine you have a map,
Okay.
and
let's check.
each point on the map represents a different blood pressure reading.
I'm with you.
Quantile embedding essentially creates a map where similar blood pressure readings are clustered together.
So instead of just seeing a bunch of numbers,
Right.
ETHOS can visualize the relationships between those values in a more meaningful way.
Exactly.
Okay.
And this allows the AI to capture the nuances of numerical data and understand how it relates to other events in a patient's timeline.
That's pretty clever.
It is.
So by breaking down the data into tokens,
Mm-hmm.
using quantile embedding,
Yeah.
and then analyzing the sequences of these representations,
Right.
ETHOS can start to build a sophisticated understanding of a patient's health trajectory.
That's a great summary.
Okay.
And all this technical wizardry leads to those impressive predictions we've been talking about.
This is all incredibly fascinating. We've gone from a high-level overview of ETHOS
Yeah.
to exploring the technical details of how it processes and analyzes data.
Mm-hmm.
It's amazing to see how these complex mathematical concepts are being applied to revolutionize healthcare.
It is truly remarkable.
But we've only just begun to explore the potential applications and implications of this technology.
That's true.
I'm ready to dive into those next. Let's explore how ETHOS might change the way we approach healthcare
Okay.
and what it could mean for patients and doctors alike.
Mm-hmm.
Okay, so we spent the last two parts really getting into the nuts and bolts of ETHOS,
Yeah.
how it works, the tech behind it,
Mm-hmm.
and its impressive accuracy.
Right.
Now, I'm really curious about the practical side of things.
Okay.
How could an AI like this actually be used in real-world healthcare settings?
Well, that's where things get really exciting.
Okay, I like exciting.
One of the most promising applications of ethos is in personalized medicine.
Personalized medicine. Okay.
Imagine a future where treatment plans are tailored not just to a patient's diagnosis, but to their unique medical history,
Okay.
genetic predispositions,
Yeah.
and even lifestyle factors.
So instead of a one-size-fits-all approach,
Right.
we're talking about treatment specifically designed for each individual.
Exactly. Ethos could analyze a patient's PHT,
Right. Their unique health timeline.
their unique health timeline, and simulate different treatment pathways
Okay.
to see which one is likely to be most effective.
That sounds incredible.
Yeah.
It's like running simulations to see how different treatments might play out
Yeah.
before actually administering them.
That's the idea.
Okay.
And this kind of personalized approach could lead to better outcomes, fewer side effects,
Right.
and even lower healthcare costs in the long run.
So less trial and error
Exact.
and more targeted effective care from the get-go.
Mm-hmm.
Are there other ways ethos could be used to improve healthcare?
Absolutely. Ethos could be a game changer for preventative care.
Preventative care. Okay.
By analyzing a patient's health data,
Right.
Ethos might be able to identify early warning signs of certain conditions,
Interesting.
even before any symptoms appear.
So it's like having an early warning system for your health.
That's a great way to put it.
Okay.
And with early detection, we can often intervene earlier and prevent a condition from progressing or even developing in the first place.
That could be huge for chronic conditions like heart disease or diabetes.
Exactly.
Imagine if ethos could alert someone that they're at high risk and recommend lifestyle changes or preventative treatments before the condition even develops.
Right. And it's not just about predicting individual health outcomes.
Though there's more.
Ethos could also be used at a population level to identify trends and patterns in disease outbreaks or the spread of infections.
So public health officials could use it to track the spread of a virus
Yes.
and implement targeted interventions.
Precisely, it could help us better prepare for and respond to public health emergencies.
This all sounds incredibly promising.
It is.
But as we've discussed, there are also challenges to address.
Of course.
What are some of the hurdles that need to be cleared before an AI like Ethos becomes a regular part of healthcare?
Well, one of the biggest challenges is integrating ethos into existing healthcare systems.
Right.
We're talking about complex systems with lots of moving parts and varying levels of technological adoption.
So it's not just about developing the AI,
No.
but figuring out how to make it work within the real world of hospitals, clinics, and insurance companies.
Exactly. It will require collaboration and coordination across different stakeholders, including healthcare providers, technology developers, and policymakers.
And of course, there are the ethical considerations we talked about earlier, like ensuring data privacy and addressing potential biases in the AI.
Those are crucial considerations.
Yeah.
As with any powerful technology, we need to be mindful of the potential risks
Right.
and ensure that ethos is used responsibly and ethically.
So we're talking about a future where AI plays a more prominent role in healthcare,
Yeah,
but a future where human judgment and oversight are still paramount.
absolutely. AI should be seen as a tool to augment human intelligence and expertise, not replace it.
We've covered a lot of ground in this deep dive.
We have.
We explore the technical intricacies of ethos,
Mhm.
its impressive predictive abilities, and the myriad ways it could revolutionize healthcare.
We did.
We also discussed the challenges and ethical considerations that need to be addressed as we navigate this new frontier of AI in medicine.
It's a fascinating and complex landscape.
It is.
Thanks for joining us on this deep dive.
It was my pleasure.
We hope you found it insightful.
I certainly did.
Stay curious and keep exploring the world of AI and its impact on our lives.
All the time.